Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Yesterday, we were talking about functions, and we took our time with it on purpose. I want to make sure that you really understand what a function is. So today we're going to continue with that, and then we'll go forward with our homework. So no stress, okay, guys? No pressure, okay? No judgment. What's a relation, guys? Any set of ordered pairs. Well done. Thank you. Good job, brother. Now, what's a function, guys? Guys, you have notes. You can read it. What's a function, guys? Yes, sir. Okay, you're reading right from the notes, which is nice, but that doesn't mean that you learned it. Anyone can read it. What does a function mean? Yes, sir. There we go. I like that one. It's a relation where there's exactly only one y for every x. You can only have one dependent variable for every given independent variable. Guys, we've got to learn that. That doesn't mean that you read it from the notes when I ask you. That means you go home, you study it, you practice it, okay? Thank you for trying. I really appreciate it, and great job on the answer. So, with that in mind, when we're talking about functions, there's always an independent and a dependent variable. We've talked about this as well. The x value is the independent. Sometimes it's called the input, okay? That's what the x values are. It's also the domain. The dependent variable is the y, or the output, or the range, okay? So in these particular examples, I want you to simply identify the independent variable and the dependent variable. So in the winter, more electricity is used when the temperature goes up, and less is used when the temperature goes down. So who can tell me who's the dependent variable here and who's independent? I saw a hand go up. Yes, sir? The electricity used, right? The electricity used is dependent on what, my brother? That's exactly right. Independent is the outside temperature. Does that make sense, guys? Do you see why that happened? Does that make sense to you? Do you see the relation? Yes, sir. Because the hotter it is, don't I turn up my air more? Or turn down my air? If it's super cold outside, don't I use more heat? So the amount of electricity used depends on your temperature outside. If it's 70 degrees outside, me personally, I'm going to open up all my windows. The electricity used for that day is going to be very, very little. But if it's 100 degrees outside, which it is in Miami in August, I'm going to crank my AC, and it's going to probably be running all day long. So the electricity that I use is dependent on the temperature outside. Thank you so much for your honesty. Does that make sense to you guys? Don't be afraid to ask ever. Okay, next. The cost of shipping a package is based on its weight. Who's dependent? Who's independent? You got an answer for me, Bubba? Let's try. Who's dependent here and who's independent? The cost of shipping a package is based on its weight. No, the weight is not dependent. The weight is independent, actually, because I can choose to send a card, which is going to weigh less than an ounce, or I can literally choose to send you a huge basket with fruits, right? And chocolates, and that may weigh 3-4 pounds. The cost of shipping is dependent, because the larger the package, the higher the cost. Does that make sense, kid? Promise? Does that make sense to everybody? Yes, sir, my brother. Oh, because I'm not paying attention. I apologize. The independent variable is not independent. It's the weight. Sorry about that. Thank you for getting my back. Thanks, kid. How about C? The faster Mike walks, the quicker he gets home. Yes, sir. The dependent is the time to get home. Yes. And what's independent? That's exactly right, my brother. And the independent is the walking speed, how fast he walks. Because the faster you walk or the faster you go somewhere, the less time it takes you, right? If you got to go 60 miles and you're driving at 60 miles an hour, it takes you 1 hour. But if you got to go 60 miles and you're driving at, this is highly illegal, do not do this, this is just a scenario, and you're driving at 120 miles per hour, you'll get there in half hour and get like 5,000 tickets and go to jail. So don't do that. But hopefully you see my point. Does that make sense? Okay. How about D as in David? What do we got? Come on. What do we got? Got it? Let's go, brother. Yeah, I love that you want to try it. Let's go. What you got here, kid? Company charges $10 per hour to rent a jackhammer. Jackhammer is just an object. The cost, yes, of the rental is dependent. And what is it dependent on, my brother? No, it's not weight. Think about it. Company charges $10 per hour. No, Papa, we're not talking about distance or weight. The company charges $10 per hour. Your cost is dependent on what? Help them out, guys. On the hours. The number of hours is independent. Look, check it out, Papa. I can go to the store, okay? Let's just say that it costs, not just say, it's $10 per hour. Y equals 10x. I can go to the store and say, no, I don't want to pay that. I rent it for 0 hours. What's my cost? 0. But I can go and say, okay, I got to rent it. I got a huge job, and I'm gonna use it 10 hours. Now my cost is $100. So the more hours I spend, the higher the cost. Yes, sir. But that's the point. We don't know how many hours. That's why it's independent. Because I can choose to rent it for 0 hours, or I can literally choose to rent it for 1,000 hours. Literally. No, we're trying to just figure out who's dependent and who's independent. And independent here is the number of hours. Because I can choose to rent it for 0 hours, 1 hour, 7 hours, 9 hours, 6 hours, 3 hours. But my cost depends on that. The more hours I rent, the higher my cost. The more expensive it will be. That's why the cost is dependent. And the independent is the hours. Correct. You see that, my brother? Promise? Thank you for your honesty. Sir. No, the cost is always dependent because any cost depends on what you purchased, right? Yes, sir. Okay, E, talk to me. What is it, my man? Okay, so the dependent here is the cost. Yes, total cost. And what determines this total cost? What's the independent here? The number of pounds, yeah. Number of pounds of apples. Or, like you said, the weight of the apples in pounds. Does that make sense to everybody? Promise, guys. Okay. May I continue, gentlemen? Thank you. Okay. Now that we know what a function is, and again, little reminder, a function is any relation where there is only one y value for any given x value. A function is a relation where there is only one output for any given input. All right? Now, a function rule is an equation that represents the output value y in terms of an input value x. You can write a function in function rule notation. Shown below are examples of function rules. Let me explain this because this is definitely a huge thing on the SAT. And most people never really get it. So I'm hoping, just like the definition of functions really click for some of you, I'm hoping this clicks for you today as well. Guys, remember that the output is the dependent variable, it's the range, it's the y value. So the y value here is my output. The x, remember, is the independent variable. It's the input. It's also known as the domain. So my x is the input. You with me? All I'm doing in function notation is rewriting the output y in the form of f of x. F of x is the same thing as y. It's the answer. It's the output. It's the range. It's the dependent. Now, why do they put this f parentheses x? This is truly read as f of x, which means function f of x, or function f with independent variable x. This is just telling you, hey, reader, I'm going to call this function f, but I'm telling you that the independent variable is x. Just like if I said g of c. This means this is function g with independent variable c. So f of x is just a fancy way to write the output, literally. Sir? That's a great question. When you figure it out, guys, let me know. I can't answer it because you don't know what you're asking. Oh.
There's an x and a y, right? And x equals 3. Would you put 3 in the x that's with the f? Or since that's the y, would you put... So if you're given like...
Okay, how about let me teach, and then we'll go from there. Okay. All right, so guys, how does this work? If I were to tell you find f of 1, f of 1 is simple. They're saying, hey, we're using function f, but this time we're making the independent variable a 1. So I replaced, in that f of x, I replaced x with 1. So what am I going to replace this x with? A 1. So f of 1 is 3 plus 2, so f of 1 equals 5. So let me explain this. F of 1 equals 5. The x value is the 1. The y value is the 5. Because f of 1, the function itself, f, is 5 when the x is 1. Now, it's very important to know the subtle differences in things. For example, this is not in your pre-made notes. If I were to tell you f of x equals, let's just say, negative 2x plus 3. I want you to find each. And I tell you, number 1, I want you to find f of negative 2. I'm using function f, and what am I replacing the x in function f with? So f of negative 2 will equal negative 2 times negative 2 plus 3. So what does f of negative 2 equal? 7. So what's the ordered pair here? No, what's the ordered pair here? What's the ordered pair here? Negative 2 comma 7. Guys, we just went over this. This is your x value. The answer to the equation is your y. Remember, the independent here is the x. The answer, when you plug in that x, is the y. That's your f of x. Now, what if I told you this, though? So f of negative 2 we know equals 7. What if I told you this? F of x equals, I like this, equals 9. Find x. Now this is a good one. Now here, what did I give you guys? I gave you the y. Very good. So what I gave you here was 9, which is f of x, equals the function, which is negative 2x plus 5. Does everyone see that? Don't just say yes to make me, and it's not 5, it's 3, sorry. Don't just say yes to make me happy, guys. What's going to make me happy is that you're learning. F of x is 9. A lot of people replace the x with 9 there, but are they telling you to replace the x with 9? They're telling you the f of x is 9. Doesn't f of x equal negative 2 times x plus 3? What did they give you, the x or the f of x? So do you see why I replaced the f of x there with 9? Now, how do I solve for x here? That's right. This should be, just like autopilot. Negative 2 divided by negative 2. So x equals 3. So what's the ordered pair here? I don't know why you're getting negative 3 from. I'm sorry, it is negative 3 because I'm not paying attention. Negative 3, comma, 9. That's my x. That's my f of x. Do you guys see this? This is like so huge, I can't even tell you. And teachers drop the ball on this all the time. I don't want to be that teacher. Does every single human understand this? Or at least see it for the first time, or is really starting to grind it out? Does everyone see this? You promise. Yes, sir, Aaron. Which one? The green part. Okay, well, I tell you that f of x, thank you for your honesty, by the way. F of x equals 9, correct? Doesn't the function f of x equal negative 2x plus 3? What did I give you? Did I give you an x or did I give you an f of x? So isn't f of x 9? Because for the blue part, buddy, I was asking for find f of negative 2. What did I replace there? The x or the f of x? Just the x. Do you see the difference? It's a brilliant question you just made. I don't know if you understand how powerful that question was. It's very good. Do you see that subtle difference, though? You promised me. Thank you, my brother. May I continue, gentlemen? All right, let's do this. All right, so now it's just Mickey Mouse time. Okay? I have the function f of x equals negative 2x plus 5. I want to find f of negative 3. What am I replacing in this function? X with what? So what am I going to replace in every x in this function? Yeah, so I got negative 2 times x, which is negative 3, plus 5. Because didn't I replace, this is f of x. Did I replace x with negative 3? So I have to replace every x in this function with negative 3. So f of negative 3 will equal 11. What's the ordered pair here? When x is negative 3, my f of x is 11. Thank you. Next, f of 1/4. What am I replacing the x with here in this particular case? So what am I going to replace in the x in every x of this function? Okay, so I'm going to go negative 2 times 1/4 plus 5, which is going to equal 4.5. Very good, or 4 1/2. Very good, my brother. What's my ordered pair here? 1/4, comma, 4.5. The x is the independent. That's my x. The answer is my f of x. That's my output. That's my y. Yes, sir. You can have a decimal and a fraction next to each other. Yes, sir. How about f of 0? What am I replacing the x with here? So what am I going to replace every x in the function with? So I got negative 2 times 0 plus 5. So that equals 5. What's my ordered pair? When x is 0, y is 5. Do you guys see this? Talk to me. Negative 2 times 0 is 0. 0 plus 5 is 5. Because 5 is not an x. I'm just replacing the every x with 0.
Every x.
Thank you, Papa. Now, what if I told you this? F of x equals negative 11. Find x. Do it. I'm going to pause it. Don't tell me what to do. You do it on your paper. Go. I'll be right back. Okay, guys. Let's take a look at this. F of x is negative 2x plus 5. Did they give you here a value of the f of x or the value of x? F of x. So doesn't the function f of x, which is now negative 11, doesn't that equal negative 2x plus 5? I'm solving for x. So I subtract 5 to both sides. Negative 16 equals negative 2x divided by negative 2. So x equals 8. What's my ordered pair here? When x is 8, y is negative 11. Guys, do you see the differences here? I'm replacing the x's in these. I'm replacing the y in here. Yes, no, maybe, kind of, sort of. All right. Tickets to a concert are available online for $35 each plus a handling fee of $250. The total cost of a function, the total cost is a function. I skipped one there. Keep going. It's there. So tickets to a concert are available online for $35 each plus a handling fee of $250. The total cost is a function of the number of tickets bought. So listen to that. The total cost, remember that's my f of x, right? That's my y, total cost, is a function of the number of tickets bought. That's my x. That's my independent. Because I could buy 0 tickets, or I can be generous and decide to buy tickets for everyone in my family. It is independent. Okay? So what is a function rule? What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. So what do you think about my brother? F of x, where this is function f and x is the independent variable, which is the number of tickets bought, equals 35x plus a handling fee of $250. Thank you, my brother. Now, does that make sense, guys? Now, evaluate the function for 4 tickets. So what am I replacing here? What is the 4? Is that the cost or is that the number of tickets? So this is f of 4 equals 35 times 4 plus 250. 35 times 4 is 140 plus 250. So you've got 142.50. My brother, I'm sorry I saw your hand. I kind of ignored you, but not on purpose. I just wanted to keep flowing. What's up, my man? Thank you, my brother. Does that make sense, guys? You promise? Okay. May I continue? No? Talk to me. Who said it? Yes? Okay. You're buying bottles of a sport drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of the purchase? Evaluate the function for 15 bottles. What do you guys got here? Talk to me. Okay, f of x, where f stands for what? No, f stands for what? That's just the name of the function. Who's the independent variable here? Guys, you're answering 7 steps ahead. Listen to the questions. What does this f represent? Just the name of the function. This is function f. If it was g of x, it'd be function g. The f is just the name of the function. What is x here? No, you can replace it with 15, but what does x stand for? What does the x stand for? The independent variable. Guys, okay, this is why I asked 17 times and all of you say yes, but it's really no. So let's have honesty in our hearts. Let's remember that you're with a teacher who does not mind reteaching. And let's be honest with ourselves. F of x. This is f. This is function f with independent variable x. Now, f of x itself, that's my y, or the output. That's the answer, the whole f of x. That's my whole function. But this is function f with independent variable x. What don't we see, please? Because I want to help you, but I cannot help you if you don't let me. Yes, sir. Okay. So now, no, now I got to get the function. So f of x equals what? For this particular function, $1.19 for every x where x is the number of bottles. Talk to me, guys, please. And I'm very worried because when I said what's x, you guys are saying is the dependent variable. No, it's not. F of x is the dependent variable. Because f of 15 now equals 119 times 15. Guys, do you see that the x is the independent? I'm replacing the x with 15 here. And what's the dependent? The actual answer. So f of 15 equals 119 times 15, which equals $17.85. Why do you guys think I keep telling you what's the ordered pair here? What's the ordered pair here? When x is 15, what's my f of x? So when x is 15, my total cost, which is my y, which is my f of x, is $17.85. This is huge, guys. Are you seeing this? Okay. May I continue? Okay. Last but not least. Hold on, let me move this guy here. Okay, there we go. In 2002, the Prestige oil tanker sank and started leaking oil off the coast of Spain. The oil slick took the shape of a circle. Suppose that the area A in square miles of the circle contaminated with oil can be determined by using the function. Check it out, guys. Let's analyze this for a second. Function A of t. What does A stand for? It's just a function name. This is just function A. And who's the independent variable? T is the independent variable. The whole function is this when you put it all together. Does that make sense? Okay. So it's given by this function A of t equals 0.25 pi t squared, where t represents the number of days since the tanker sprang the leak. Identify the dependent and independent variables. Who's dependent here? Who's independent? Independent, but what does T stand for, guys? What is the independent here? No, read. The number of days since, no, since it leaked. Again, guys, I'm not trying to be rude here, but it's not like it's a magical thing that you got to look for, guys. You're not trying to look for the leprechaun at the end of the rainbow. All you got to do is read. Read. T represents the number of days since the tanker sprang a leak. So when I say to you guys, what is T? You actually tell me things like days of the year. What? Read. Now, what does the dependent? What is the dependent? Think before you speak. Yes, sir. The area. The area of the spill. If you would have answered square miles, I would have probably marked that wrong. Area is square miles, but square miles of what? Square miles of cookies in a bakery? Square miles of water in the ocean? Square miles of salt at the Dead Sea? Square miles of what? Okay, we have to articulate what we're answering. Thank you, my brother. And now, last but not least, now evaluate A of 30. Well, we need to plug it in. So what am I replacing here? Am I giving you the dependent or the independent variable? Am I giving you the area or am I giving you the days since the spill began? I'm giving you the independent, the days since the spill began. So A of 30 equals 0.25 pi times 30 squared. So this is going to equal 0.25 times pi times 900. And 900 divided by 4 is 225. So this will equal 225 pi square miles because it's an area. So after 30 days of the leak, function A has an area of 225 pi square miles. Yes, sir. 0.25 is 1/4. 1/4 times 900 is 225 because 900 divided by 4 is 225. Does that make sense, gentlemen? Promise? Ask me now because we're done. All right, thank you so very much. I hope you learned a lot. God bless you and have a great day. Bye-bye.